Welcome to Powered by Tesla.
Welcome! Today, we're uncovering the simple, kind of boring-looking device that, no joke, makes our entire electrical world possible. It has zero moving parts, but it's the thing that moves our entire civilization forward.
So let's just jump right in with a massive question. Think about it. It's one thing to generate a bunch of electricity, but how do you get it from, say, a huge dam in the middle of nowhere to your phone charger without it all just fizzling out? That is a huge problem.
You know, the heart of this whole challenge is just wasted energy. Engineers have a name for it. They call it line loss. And honestly, it's a fundamental physics hurdle we absolutely had to clear to build the modern world we live in.
Right. That energy doesn't just disappear into thin air. It actually escapes as heat, literally warming up the power lines themselves. And all that heat? That's just wasted power that never makes it to your house to power your TV. So how in the world do you plug those leaks?
Well, the secret is this really clever trade-off. It turns out, if you crank up the voltage way up and in turn lower the current, you can send that power over incredible distances with hardly any loss at all. But you see the catch, right? Power plants don't make electricity at those crazy high voltages, and your house would, literally explode if you tried to use it. We needed a way to change the voltage.
And that brings us to the hero of our story, the transformer. It is, without a doubt, one of the most important and useful electrical devices ever invented. Just a brilliantly elegant solution to this massive challenge.
So at its core, what is a transformer? It's basically a voltage converter. It's a static device, which is a fancy way of saying it does its job without any spinning gears or moving pistons. And its true brilliance is just how simple it is.
And this right here, this combination of features is what makes them so unbelievably ingenious. Because there are no moving parts, they are super rugged, they're incredibly reliable, and they need almost no maintenance. It's this beautiful simplicity and toughness that has made them the absolute cornerstone of our power grid for more than 100 years.
And get this, they are so good at their job, a modern power transformer wastes almost zero energy doing its thing. We're talking efficiencies as high as 99%. That's almost perfect. So, how does this simple box pull off such an incredible magic trick?
So, how does it actually work? Well, the magic isn't really magic at all. It's a fundamental principle of physics that the legendary Michael Faraday figured out, and it's called electromagnetic induction. Okay, it's this beautiful three-step dance. And the key thing to get here, this is the wild part, is that there is no electrical connection between the two coils. They never touch. All the energy gets transferred wirelessly, carried from one coil to the other by that pulsing magnetic field. And this slide right here illustrates the secret sauce. The trick to changing the voltage is just the ratio of wire turns between the two coils. If you have more turns on the second coil, the voltage goes up. If you have fewer turns, the voltage goes down. It is literally that simple.
Think of it like a gearbox for electricity. You can't just create energy out of nothing, right? So when you increase the voltage, you have to decrease the current, and the other way around. And this perfect, predictable trade-off is exactly what's needed to solve that big power transmission problem.
Okay, so we said transformers are 99% efficient, which is incredible, but it's not 100%. So where does that last little 1% of energy actually go? Yeah, if there's no mechanical friction from parts rubbing together, there has to be some other kind of loss happening, right? And there is. You can think of it like the energy gets hit with two very small taxes as it passes through.
So here's the deal. There's a constant, low-level loss called core loss. This just comes from the iron core being magnetized and demagnetized over and over, and it happens as long as the transformer is turned on. Then, you have a variable loss called copper loss. This is just heat from the normal resistance in the copper wires, and it gets bigger the more electricity you're trying to pull through it.
Okay, now for the fun part. Let's put all these pieces together and actually see these silent giants in action. We're going to follow the complete journey of electricity, from the moment it's created at a power plant all the way to the outlet in your wall. So, the whole journey kicks off right here. An absolutely enormous step-up transformer takes the power that was just generated and jacks the voltage up to an insane level, sometimes 500,000 volts, to get it ready for its super efficient trip across the country. Then, once that super high voltage power gets near your region, it pulls into what's called a substation. And inside, another large, but this time step-down transformer brings that voltage way down to a more manageable level, something like 7,000 volts, to be sent out to local towns and neighborhoods.
And finally, the last step happens right there in your neighborhood. You know that gray can you see on the utility pole, or maybe a green metal box on the sidewalk? Yep, that is one last step down transformer, doing the final conversion to the safe, usable 240 volts that actually power your life.
I mean, just try to imagine it for a second. Without transformers, our electrical grid, the one we rely on for everything, just wouldn't be possible. It couldn't exist. We'd literally need a power plant in every single neighborhood. The whole idea of sending power from huge, remote solar farms or dams would be a complete non-starter. It'd be ridiculously wasteful and expensive.
It really is the invisible, indispensable backbone of modern life. A simple, elegant, century-old invention that just quietly and efficiently hums along, making everything else we do possible. It's a fascinating question, isn't it? In a world where everything is constantly being disrupted and updated, some simple, elegant ideas are just perfect. What makes them so timeless? Something to think about. Thanks for joining this explainer.
Like and share this video. And don't forget to subscribe to Powered by Tesla.